In section 3.8, we're going to review direct, inverse, and joint variation. In Algebra 2, we discussed these topics. Direct variation was any equation of the format y equals k times x to the nth power, where k was called the constant of variation. Direct variation occurs when you have a constant being multiplied by the input. So when we did these problems last year, we showed you how to do them in two different ways. I will go over both of those methods. So in this example, if y varies directly as a square of x, and y is equal to negative 54 when x equals 9, find y when x equals 6. One way we had of doing this problem was to start with the given information and determine the constant of variation, so that we would have an equation we could use to find the end result. So the equation again was y equals k times x to the nth power. Since this problem says that y varies directly as the square of x, that means that we're going to use y equals kx squared. Well, I know that y is equal to negative 54 when x is equal to 9. So I'm going to plug it into that equation, and we're going to solve this for k. So negative 54 is equal to 81k. So k is going to be negative 54 over 81. So now I have the equation y is equal to negative 54 over 81 x squared. And I guess I probably should just reduce this fraction. This reduces to negative 2/3, which is a lot nicer than using negative 54 over 81. All right, now that we know what the equation is, now we can go back and find y when x equals 6. So y is equal to negative 2/3 times 6 squared. Don't forget the original problem said it varies directly as the square of x, so we got to square the x. So y is equal to negative 2/3 times 36, which is negative 24. And that's our final answer. However, with direct variation, we actually had another way of going about doing this problem. It was using a proportion. So it was x1 over y1 is equal to x2 over y2. But since we need to have squares of x's, don't forget it said square of x, that's an important thing. It told me that when x is 9 squared and y is negative 54, we want to find y when x is 6. So I can create a proportion. A lot of times students who reason out the answer to this problem have really just done a proportion. So 81 over negative 54 is equal to 36 over y. Oops. Let's make that a y. And then we're just going to cross multiply. So 81y is equal to negative 1944. And then when you divide by 81, you get negative 24. So the two ways of approaching this problem were to first find the constant of variation and then use the new equation to find your final answer. But with direct variation, you can also use this proportion. x1 over y1 is equal to x2 over y2. The problem with these particular variation equations is that you need to be careful about what the original problem tells you to do with some of the variables. They may tell you to square them or cube them or square root them. So watch out for those phrases. The second type of variation is called inverse variation. Inverse variation occurred when you took the constant of variation and divided it by the input. So we use the equation y equals k divided by x to the nth power. It also has a proportion that goes with it, and the proportion is x1 over y2 is equal to x2 over y1. So let's look at this problem. If y varies inversely as x, and y equals 3 when x equals 4, find y when x equals 15. So they didn't say anything about performing any other operations on x, so we're not squaring, cubing it, square rooting it, none of that. So we're just going to use y is equal to k over x. So I know that y is 3 when x is 4. This is just a proportion. If you don't see it, there it is. So k is equal to 12. And now that I know k is 12, I know the equation is y equals 12 over x. And now we want to find y when x is 15. So all I have to do is plug in 15 for x and reduce that fraction, and it reduces to 4/5. What if I wanted to use the proportion instead? So we're going to call this y1 and x1. So we want to find y2 when x2 is 15. I like to do that within the actual problem, and it kind of helps me using this equation. It tells me where to plug things in, basically. So 4 over y2, because that's what we're trying to find here, is going to equal 15 over 3. So 15 y2 is going to equal 12. And look, when you divide, you get 12 over 15, which reduces to 4/5. The third type of variation was called joint variation. Joint variation occurred when you had more than one input. So in this particular equation, y equals k, x to the nth, z to the nth, the two inputs are x and z. Because joint variation is very similar to direct variation, since it's being multiplied by the constant of variation, its proportion looks like this. x1 z1 over y1 is equal to x2 z2 over y2. Now let's do an example of joint variation. If y varies jointly as x and the cube of z, and y equals 16 when x equals 4 and z equals 2, find y when x equals -8 and z equals -3. So we're going to start by writing our equation. It varies jointly as x and the cube of z, which means we have to write that as z cubed. So I know that y is 16 when x is 4 and z is 2. So now I can solve that equation for k. 2 cubed is 8. 8 times 4 is 32. And then when I divide by 32, I find out that k is 1/2. So we're going to use the equation y equals 1/2 xz cubed. Now we're going to go plug in -8 for x and -3 for z. So y is equal to 1/2 times -8. And what was the other one? -3 cubed. -3 cubed is -27. And then -27 times -8 is +216 times 1/2 is going to be 108. So y is going to equal 108. If I want to do this using the proportion, I would do, these are x1, y1, and z1. And I want to find y2 when x2 is -8 and z2 is -3. So x1, remember that if it says that z is cubed, z's got to be cubed. So we're going to do x1 z1 cubed over y1 is equal to x2 z2 cubed over y2. So 4 times 2 cubed over 16 is going to equal -8 times -3 cubed over y2. So 2 cubed is 8. 8 times 4 is 32 over 16 is equal to, and then we just did -3 cubed is -27 times -8 is, I think, 20. Not 20, 216. And then I get 32y is equal to 3456. And 3456 divided by 32 is 108. The only time that the proportions aren't going to work is when you have multiple variations going on in a problem. So in this example, if y varies jointly as x and z and inversely as the square of w, the equation we're going to start with is going to be y equals kxz over w squared. Because it was jointly with x and z, which means x and z get multiplied by the constant, and inversely as the square of w means that w squared is in the denominator. Now, we're going to plug in 3 for y, 3 for x, 10 for z, and 2 for w. Don't forget we're squaring it. And we're going to solve for k. So I get 30k over 4. This is just a proportion, so I'm going to end up with 30k equals 12. So k is equal to 12 over 30, which reduces to 2/5. Now that I know that k is 2/5, 2/5 xz over w squared, now we can go find y when x is 4, z is 20, and w is 4. So y is going to equal 2/5 times 4 times 20 divided by 4 squared. 2/5 times 4 times 20 is going to be 32. 4 squared is 16, and 32 divided by 16 is 2. In the next problem, we're going to determine what type of variation is going on in the equation and write a statement of variation relating the variables of each equation. And then we're going to determine what the constant of variation is. So a lot of times when you have problems involving x and y, it's probably best if we rewrite the equation so that it says y equals. This is just a proportion, so 7y is equal to x to the 4th, which means that y is x to the 4th over 7, which is the same thing as 1/7 x to the 4th. The statement of variation is that y varies directly because the x is being multiplied by the 1/7 as maybe I'll say x to the 4th power as x to the 4th power. And the constant of variation in this problem is going to be 1/7. In this next problem, this is the formula for the area of a rectangle. So we're going to say that the area A varies jointly. How did I pick jointly? Because there are two inputs when you're finding area. Those two inputs are length and width. So it varies jointly as the length L and the width W. What's the constant of variation in this problem? It's 1, because if there's no number in front of L and W, there really is a number there, it's 1. Oops, this is not B. Let's try that again. So remember I said a moment ago, if you have problems that have x's and y's in them, we should probably just solve the equation for y. So xy is equal to -3, so y is equal to -3 over x. Now I can tell you that y varies inversely as x. And the constant of variation is -3. Sometimes we want to do real-world application problems that involve variation. A lumber company needs to estimate the volume of wood a load of timber will produce. The supervisor knows that the volume of wood in a tree varies jointly as the height h and the square of the tree's girth g. The supervisor observes that a tree 40 meters tall with a girth of 1.5 meters produces 288 cubic meters of wood. Let's start by writing an equation to represent this situation. Since it says the volume of the wood, we're going to use V for volume. And the volume of the wood varies jointly as the height and the square of the tree's girth. So we're going to start off with V is equal to KHG squared. But now they gave us some numbers to plug in so that we can find the constant of variation. They told us that the volume is 288 cubic meters, when the height is 40 meters and the girth is 1.5 meters. Don't forget we need to square it. So 40 times 1.5 squared is 90. And then when I divide 288 by 90, I get 3.2. I'll write it here. So the equation is V is equal to 3.2 Hg squared. Now we're going to use that equation to find the volume of wood that the supervisor expects to obtain from 50 trees averaging 75 meters in height and 2 meters in girth. So we're going to start by plugging in 75 for the height and 2 for the girth. 3.2 times 75 times 2 squared is 960. But that's not the final answer because we want to find the volume from 50 trees. Well, all I have to do is multiply that answer by 50 because that's the volume for one tree. So the volume for 50 trees is 960 times 50, which is 48,000. And it's going to be meters cubed. And that is direct, inverse, and joint variation.